today is we're going to chat about how to use the chain rule in physics problems. So as you know, I like to kind of give a little backstory and lock these down in some sort of prior knowledge that you have. So let's just talk about this scary concept of chain rule from calculus in a more basic idea of unit conversion. All right, now we've all done unit conversion. So for example, like you just want to convert something like, hey, 1 hour, let's convert that into seconds. All right, no big deal. So you just do your unit conversions. You're like, well, 1 hour times, well, let's see, in 1 hour, there happens to be 60 minutes. And in 1 minute, there happens to be 60 seconds. So by doing this, you are basically going to cancel out, not seconds, Samansky, do better in life. Seconds. You're going to cancel out your minutes because, those washed out. Your hours go away. And so now you're left with what you wanted, which was seconds. So now let's take what we know and let's just slap some, calculus onto that. All right. So let's now put this into our fundamental chain rule. So this is the fundamental chain rule idea. Fundamental chain rule. All right, so basically, let's say we've got some derivative, say dA dE. All right, I'm just picking letters. It doesn't matter. This is made up. If I want, I can be like, okay, well, how do I rip that apart? It's almost like the opposite of unit conversion. We're just going to rip it apart and see if we can get the pieces out of it. So I could do dA dB times dB dC times dC CD, there you go. It's that DD. It's freaking my head. Times, really should have just gone to C. DD, just looks like I'm doing double Ds. DE. All right, cool. So now, just like we got the stuff to cancel out here, like those were minutes, those were hours, and they went away, well, basically the exact same thing is happening here. We are getting these guys to knock each other out. We're getting these guys to knock each other out. We're getting these guys to knock each other out. So as you can see, once all that is said and done, we got what we were looking for of dA dE. And so that's the chain rule, okay? So you can use it to put stuff together. You can use it to rip it apart, to basically get the pieces you want. So how are we going to use this in, say, physics? Well, let's just kind of go through a problem here. All right, so let's get into a little example problem going here. And so here's our scenario. We've got this equation, velocity equals negative 10x squared. So you've been told, hey, the speed of the object is relative to its position. But we would like to know, okay, well, if this is a true statement, what is acceleration? All right, what's the acceleration? So that'd be the type of scenario. Well, we can start ripping that apart because we're like, well, man, acceleration's not in here. But we know that acceleration has a deeper meaning. So remember, acceleration is your rate of change in velocity, dv, divided by the rate of change in time. So that's dv dt, okay? And now, if we apply the chain rule to this concept, we can start changing it. So we can multiply this by dx. That's the bell. So if we start doing what, we can rip this apart. We can say that's actually equal to, not multiplying, my bad. So we can rip this apart, and we can say, well, that's dv dx times dx dt. And as we know, this piece right here is what we'd like to get to, right? Because we want those x and t's. But here, notice that's what's going to cancel out. So we're just going to kind of separate stuff. And so the cool thing is that this right here, dx dt, this guy right here, that's velocity. All right, that's velocity. So we're using that chain rule. We're using that concept of just unit conversion to try and get to pieces we want to work with. So now that we have all this kind of broken down, we can go back to our main idea here. So I'm just going to scroll up, give me some space to work with here. And so we're now going to actually look from the parts. All right, so remember, we're using the same skills from unit conversion. We're breaking them down into smaller parts that will yield the same mathematical result. So if we say just find dv dx, what we're really saying is find the derivative of velocity with respect to WRT to position. So all we're going to do is we're going to use the power rule. So check this out. I can go, well, dv dx is equal to negative 20x. You're like, well, wait, hold back up. How did you get that? Well, remember, all I'm doing is I am taking this value right here, and I'm taking the derivative of that to get to here. So I took the derivative of x with respect to position, and so the derivative of this side here is negative 20x equals dv dt. And so that's where I got that from. All right. So yes, I'm still working how to run this. There we go. Okay, cool. So that's where we're at. So that's where that came from. You're like, wait, Szymanski, how'd you get here? That's how I got there. Okay, cool. So now that I have that, we've got the dv dx part, so that's this chunk. So now I need the dx dt. Well, that chunk we are going to just kind of grab because, like I said, that's velocity. So we can just say that velocity equals dx dt. And if we just use our equation from above, we can get v equals negative 10x squared. And if we then plug all that in, we can kind of combine our equations. So if you think of it, this is kind of like part 1 and part 2, and so we're going to multiply them together. So this right here is my part 1, dv dx, and so I'm just going to write that out. So acceleration equals dv dx times dx dt, and I'm going to bring that in. So that is negative 20x times negative 10x squared. Why do I write cubed? Why do I write cubed? Because I know what the answer is. Negative 10x squared. And that's our acceleration. Cool. So all I got to do is multiply that through. And so when you crunch that numbers, you get acceleration is equal to 200x cubed. Now, cool. All right. So that's how you can write the acceleration. Now, in theory, you might also be asked to, say, solve for acceleration with respect to time. And so then you'd need to have some sort of equation for what x is. Now, if you watched my previous video, then you would remember potentially, I don't know if you watched them back to back, on just like the basics and using the power rule. I kind of walked through that, and we walked away with an equation that said x is equal to, at least with some manipulation, negative 10t squared plus 2. And so we would just take that and do some replacement into here. And if you just sub that in, then you'll end up getting something really wonky, which is going to happen a lot. I'm not going to lie about that. You're going to get some stuff like, why can't the answer be 5? Nope, now that we can work with crazy numbers, you got some crazy stuff going on, which is much more realistic. I mean, very rarely in life does stuff work out to be a nice clean number. So that would be like the last step, depending on what the problem is being asked you to do. But this is the fundamental idea behind how to use the chain rule, is you are just using it to manipulate some of the variables into stuff that you can actually work with using math. All right. So I hope you found that helpful. If you have any questions, please let me know. Yeah, see you in class.